All right, here's the final video in week 7 homework for the grade 11 math class. So we're still on B1 and we're in the last part of it, rational exponents. So these you may not have seen before. Rational exponents are just like our rational expressions, where it's actually just a fraction as an exponent. So rational seems to indicate fraction. Okay, so check it out. We have exponents that are fractions. So if we did 4 to the power of a half times 4 to the power of a half, check out what we have. If we use our exponent laws, anytime we multiply stuff with the same base, we can add their exponents. So what's a half plus a half? 1. So it turns out 4 to the power of half times 4 to the power of half actually equals 4. So if you think about it, what two numbers that are identical numbers would multiply by each other to equal 4? The only numbers I can think of would be 2 times 2. So how does 4 to the power of half end up equaling 2? Okay, let's try another one. Let's go 9 to the power of a half times 9 to the power of a half equals, so if we had 9 to the half times 9 to the half, if we use our exponent laws and we add exponents together, a half plus a half is 1. So this actually just equals 9. So can you think of two numbers that multiply together to give you 9 that are the same numbers? 3 times 3. So how does 9 to the power of half equal 3? So if you haven't figured it out yet, here is the key. Fractional exponents also can be written as roots. So it turns out we can write 4 to the power of a half can also be written as the square root of 4. Just like 9 to the power of a half can actually be written as the square root of 9, which equals 3. So rational exponents can be written in radical form. So let's talk about that. So we've got exponential form, and we have radical form. Okay, so let's try some. So let's say I gave you something like exponential form. So let's say I gave you something like 27 to the power of over 3. Let's say we wanted to write that as a radical. Well, this bottom number is actually the radical that we'll be taking. So we want the cube root of 27. So that's what that means. Or if we had, I'm just going to write this one again, 4 to the power of half. If we wanted to write that in radical form, it would be the square root of 4. We often don't write that little 2 because square roots are the most common that we use. So we normally just write this as the square root of 4. But there's more than just square roots. There's cubed roots, fourth roots, fifth roots, sixth roots, whatever you want. I could write 16 to the power of a quarter, and you could write that in radical form by saying, hey, the fourth root of 16. And we can even evaluate all these things. So it turns out your calculator could evaluate this. So if you typed on your calculator 16 to the power of 0.25, it would give you the same answer as if you would take the fourth root of 16, which would actually be 2, right? Because 2 times 2 times 2 times 2 equals 16. And a fourth root just means what 4 numbers multiplied by each other will equal 16, and they have to be the same 4 numbers. Well, the only ones that'll work are 2. So that's why the fourth root of 16 is 2. And we can take it a step farther by changing the numerator of a rational exponent. So let's say we had 16 to the power of 3/4. So we want to see what that looks like as a radical. So we already know the 4 part is the root. So this is like the fourth root of 16. But then what do you think this top number does? Well, another way to write this would be 16 to the power of a quarter to the power of 3, because a quarter times 3 is 3/4. So if you think that way, turns out the 3 is actually just an exponent. So we can actually just figure out what the fourth root of 16 is and then put it to the power of 3. Something else that's interesting is it doesn't matter what order you do this in. You could actually figure out what 16 to the power of 3 is first and then find the fourth root of that, which is kind of cool. So it doesn't really matter. So I would just find the fourth root of 16 because I know that's 2. And I don't know what 16 to the power of 3 is in my head. So I would do that first. And then, I would do my exponent on that. And that equals 8. So I can rewrite 16 to the power of 3/4 as the fourth root of 16 cubed. And I find out in the end it actually just equals 8. Let's try another one. Let's say we had to find out 27 to the power of 2/3. So I want to write that as a radical. So I know the bottom number is my root, so that's going to be the third root of 27. And that top number, the 2, is going to be my exponent, so it's squared. So if I wanted to evaluate that, I would find the cubed root of 27. I know that's 3, because 3 times 3 times 3 is 27. And then I still have, which would be 9. So that's how you switch from exponential form into radical form. You can go both ways. Okay. Okay, so we could also use our knowledge of rational exponents to help us simplify expressions. So let's say we had x, so let's say here we're just trying to simplify. So you know how video 2 is exponent laws? So now we could also do exponent laws with rational expressions. So like this, for example, and we could simplify it. So I don't know if this, it's actually pretty much the same as video 2, but anyways. So this is the power of a power law. So x to the power of 6 times a third would end up being 6 times 1/3, which would be 6/3, or just 2. And y to the power of 3 times a third would be 3/3, or just 1. Just simplify it to that. Or what if I said x to the power of 3 divided by x to the power of a half? If we wanted to simplify that, then we know our division law is we subtract our exponents. So we'd have to subtract 3 take away a half, which would be the same thing as like 6/2 minus a half. So we could write that as 5/2. And then we could just leave it like that, or we also could write it in radical form. So we would be the square root of x to the power of 5, if we felt like writing it like that. Yeah. So I think that's pretty much everything with rational exponents.